Hi everyone, welcome back to our channel. Today we are going to discuss about the steady state analysis of series RLC circuit. We already studied the steady state analysis of RL as well as RC, but the case is different here. We get the different combination of L and C. So in order to understand it, so let us assume we have an resistor and we have an inductor and we have an capacitor. These three are connected in parallel, and now we are exciting this with an instantaneous voltage V of t. So this V of t we can write down it as V m sine omega t. So by here you have the total Z, I am going to write it as R plus J X L ohms minus J XC ohms. So here this is a confusing part, which is greater, which is smaller. So here we are going to get three cases. Let's try to discuss it. So whenever the current, so actually you should not mark the polarities. Why I am marking the polarities? Current entering as positive and current leaving as negative is just to apply the KVL. If you apply the KVL, the things will be more better. So the total voltage is V with the terminals positive and negative. So when you the applying Kirchhoff's voltage law inside the loop. So whenever the current is leaving, or the leaving polarity of the voltage, plus V. Current is leaving, or the leaving polarity of the voltage, minus VR. So current is leaving, or the leaving polarity of the voltage, minus VL. Current is leaving, or the leaving polarity of the capacitor, VC is equal to 0. Therefore V is equal to VR plus VL plus VC. So here, uh, whether how to consider this is very much important. So therefore I am considering the first concept is XL value is greater than compared to XC value. So I can say that inductance value is greater than compared to capacitance value. Okay, so here this I can write down it as, so this XL I can write down it as plus J XL is greater than compared to minus Jx with respect to complex form I am writing, and I am multiplying this with current, and this component also multiplying with current. Therefore I can say that the voltage across the inductor is greater, but the voltage across the capacitor is lower. Therefore the we are going to get the value as V is equal to VR. What is greater? VL is greater VL minus VC. So this we have to perform the vectorial addition. V equal to VR plus VL. So from here I can write down this as I into Z is equal to I into R. How to write down the XL is, so I into J XL ohms. This I can write down I into minus J XC ohms. So here if I take I as common, Z is equal to R plus J XL minus XC. Okay, so this is what we are going to get with respect to the impedance. Okay, so this is what the impedance we observe. So how to draw the phasor diagram? Okay, so initially I am drawing, this is V R magnitude and with respect to the vector, and now we need to draw VL and VC. Already we can see here VL we are going to get as I into XL at an angle of 90, whereas, so how to draw this is I into XL an angle of 90. So 90 means, and we had already understood that the value of VL is of greater value, and this value is I into XL at an angle of 90, and automatically this will be in upward direction. But the voltage across the capacitor I can write on it as X I into XC at an angle of minus 90. So minus 90 means automatically this will come to the downward direction, and the magnitude of VC what we have taken here is less. Let us assume VC is equal to 5 volts and VL is equal to 10 volts. So now the difference, which is nothing but VL minus VC. So VL is how much? 10. VC is how much? 5. Then we are going to get 5. So this is the magnitude of VR. This is nothing but VL minus VC. So now this I have to add. So VR vectorial plus VL minus VC vectorial. So this I have to add, draw a parallel line with respect to this. Then we are going to get, which is nothing but VL minus VC, and this is the magnitude when respect to vector, and this will be the value of V. So therefore V is equal to VR minus plus VL minus VC vectorial addition. This is the vectorial representation of the phasor diagram. Okay. So now let's try to draw the next diagram also. So here we are going to have the power diagram also, that you can do it later. So the next one we are going to have, the next analysis is reverse analysis. So we have been taken XL value is greater. Now XL is smaller, but XC is of greater value. I mean, inductance is smaller, but capacitance is greater. Multiply this with current, which is nothing but I into plus J XL, so which is lesser, and this is minus J XC multiplied with current. So I can say that the voltage across the inductor is lesser, but the voltage across the capacitor is higher. Okay. So now the diagram will be replicating like this. So now when you try to draw the diagram, therefore the vector we are going to get it as V is equal to VR vectorial plus VC minus, okay. So we are going to get VC minus VL, okay. So how to draw it is very much important, okay. So VC minus VL vectorial. So first initially we need to draw the reference diagram, which is nothing but VR at an angle of 0, and already had drawn this is IXL at an angle of 90. Therefore here we are going to get the magnitude of VC, and this magnitude is I into XC at an angle of minus 90. Okay, already we have been seen here. So voltage across the capacitor is I into XC at an angle of minus 90. So minus 90 from here, this will be in this direction, but the magnitude of VC is lower, okay, but the magnitude of inductance is greater. So when you subtract this from here, so let us understand VL is equal to 5 volts and VC is equal to 10 volts, okay. So 10 minus 5, this is the magnitude we are going to get, and we are going to call this magnitude as VC minus VL. So now I want to join the vectorial VR and VC minus VL, this vectorial. So try to draw the a parallel diagram like parallel to this, and you just add it. This magnitude is VC minus VL, and this is the magnitude, and this is the vector for this, and this will give the resultant voltage V equal to VR plus VC minus VL. Okay. So these are the two cases we are going to get. So when you have a small look on this problem, you can understand it better. So initially I had taken inductance is greater. When inductance is greater, I had got the diagram in upward direction. So this I'm going to have which kind of nature? More inductance. This is more inductance nature. But here I taken capacitance is more. That's why the diagram is downward direction. Okay. So now there's one more case which overcome all these two cases, which is nothing but whenever the value of XL is equal to XC, which is nothing but plus J inductive reactance is equal to capacitive reactance. Multiply this with currents, then automatically you are going to get current. So I into XL, we are going to get the voltage across the inductor is equal to the voltage across the capacitor. Now draw a straight line with VR at an angle of 0, and at the upper we are going to get, so I into XL at an angle 90. So this is the value of VL. So this is nothing but I into XL, we are going to get VC. The magnitude of VL is equal to VC, and this is the direction of the current, and therefore when you see this diagram, V is equal to VR plus VL, and VC is also is equal to VL. VL will get cancelled, therefore V equal to VR. So I can write down V equal to I into Z is equal to I into R. R I will get cancelled. The total impedance when inductive reactance is equal to capacitive reactance, the impedance is nothing but only resistance. It's very simple to understand. Okay, that's how the ultimate diagram is going to change when inductance is equal to capacitance. This diagram is very much important. From here, we can get the impedance triangle, and from here we can get the power triangle also. Okay, and this power triangle also will be in the form of S is equal to P plus J cube. Just it indicates only inductive nature. Here they also will get impedance triangle and power triangle, and here the total apparent power is equal to P minus J cube. So this will look in the next unit, next concept. Hope you are able to understand how to draw the steady state analysis of an series RLC circuit. Hope if my way of explanation is good, please like the video and share the same video with your friends. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. I'll be happy if you say this channel to your friends, those who are unable to understand the subject. So kindly encourage these kind of free channels for the development of students as well as for the faculty. Thank you for your valuable time and listening patiently. Thank you. We'll meet in the next video how to draw the power triangle as well as the impedance triangle. Thank you for your time. We'll meet in the another video.